Everyone. In this video, we're going to talk about dilution, which again is still related to this first goal about working with aqueous solutions. You may remember the so-called dilution equation as M1V1 equals M2V2, but I like to use C for concentration. C1V1 equals C2V2. So again, C is concentration and V is volume. If you divide both sides of this equation by V2, there's another convenient way to think of this dilution equation. That would be C1 times V1 over V2 equals C2. And when you look at the equation this way, C1 can be thought of as the concentration of your stock solution. V1 over V2 is your dilution factor. Maybe you've diluted from 1 mil to 10 mils. That would be a dilution factor. And C2, that is the concentration of your dilute solution. So with this very brief background, let's see if we can do a short, quick example. Let's imagine that we had to prepare a set of standards with a linear range of 10 to 50 milligrams per liter. So these standards would be used in a calibration curve. And a calibration curve has concentration on the x-axis and some signal on the y-axis. So we want our lowest standard to be 10, and I don't know how many we prepare, but we want our highest standard to be 50. Again, that was milligrams per liter. The question is, how would you prepare 100.0 milliliters of the highest standard? And again, that would be the 50 milligrams per liter, right? How would you prepare 100 milliliters of the highest standard using a stock solution of 945.1 ppm? So I'll give you a minute to kind of read and think about that question. Now, I don't know which form of the dilution equation you want to use, but I'm just going to think of this 945.1 ppm stock solution as C1. V1 would be the unknown. How many milliliters of that stock do I need in order to prepare the highest standard, that's 50 ppm, which is the same as milligrams per liter, and V2, that would be 100 milliliters. So then solving for V1 gives 5.2, and I suppose I'll just assume 2 sig figs here in that 50. 5.2, and then I've kept a few extra digits, 9 and 0, that are insignificant, milliliters. So in other words, what I want to do is get myself a 100 millivol flask, and then I've got to figure out a way to add this 5.290 milliliters of our stock. But I'm wondering, how do we measure? How do we measure this 5.290 milliliters of stock solution? I'll give you a minute to think about all the different measuring devices that you can use in the lab. What did you come up with? Did you come up with maybe using a graduated cylinder? Or did you think a graduated cylinder isn't going to give me the type of precision that I need, 5.290? Maybe you thought, well, I should use a ball pipette that hopefully you can see here. And this is where you would use the pipette ball to use the vol pipette. But then maybe you thought, well, that only gives me 5.00 milliliters. So then you thought, I can add the 0.290 milliliters using this micropipette. So what do you think we ought to do? A graduated cylinder to do our best to get 5.29? Or should we deliver 5 milliliters plus the 0.290 milliliters using this micropipette? If it were me, I would just use the 5 ml vol pipette and not worry about 0.290 milliliters. The reason being is I only want to use one measuring device. If I use two measuring devices, the pipette and the micropipette, I have two sources of error. So that's why I would just deliver 5 mils and then recalculate the concentration of our highest standard. Let me show you that. So if we decide to deliver 5.00 milliliters of stock solution using a vol pipette, we need to recalculate. So we're going to use a vol pipette. So the concentration of our highest standard then is going to be 945.1 ppm. That's our stock. And we haven't taken 5.29. We've only taken 5.00 milliliters diluted to a total volume of 100 milliliters, giving us 47.3 ppm as the concentration of our highest standard. And that's what needs to appear in our calibration curve. So remember, we were going to have a set of standards, and rather than our highest standard being 50, it's going to be 47.3 ppm, and then you'll be measuring the signal of those standards. So the point is, the concentration doesn't have to be exactly 50, you just have to know exactly what you prepared. So this example of dilution might have been more appropriate for lab. I hope you enjoyed it, and thanks for listening.